Assalamu alaikum, sir. Today we are going to present our project Digital Parking Control System. We all know parking is a mess in most places. Manual controlling, human error, and zero efficiency. Our project directly tackles the problem by introducing a digital automated system that controls and monitors parking spaces accurately and in real time. This project was developed by our group members as a team effort where each component from logic design to circuit implementation plays a critical role in making the system work smoothly. Now moving to the block diagram of the car parking system input stage. The stage is responsible for detecting vehicles entering and exiting the parking area. Sensors placed at entry and exit points generate signals whenever a car passes through. These signals act as an input to the system and are the foundation of the entire control system. Next is the control logic section. There is a significant there is a, This is basically the brain of the system. It processes the input signals and decides whether to increase or decrease the count of cars inside the parking area. The logic ensures that the system never exceeds the maximum parking capacity and maintains accuracy at all times. The next control logic block further defines the process by coordinating signal timing and decision making, ensuring smooth transition between states without errors. Finally, we move to the display circuit block. This part visually shows the number of available or occupied parking slots. It makes the system user-friendly, allowing drivers and administrators to instantly understand parking availability. Overall, these first components work together to create a reliable, efficient digital parking solution.
Thank you, Adif, for giving this opportunity. Assalamu alaikum, sir. I am KM Shaud bin Noor. Today, I am going to explain the control logic section and the display circuits of the car parking system shown in the block diagram. First part, control logic section. The decision-making process is handled by the combinational logic and finite state machine FSM. This part of the system controls the output behavior and generates appropriate signals for the display circuits. Then second part, display circuits. If the parking lot reaches its maximum capacity, the full display circuit is activated. It sends a signal to the 7-segment display which shows the message full to inform drivers that no parking space is available. On the other hand, when parking space is available, the space available blinking circuit is activated. This blinking display attracts attention and indicates that vehicles can still enter the parking area. Thank you, sir. Now I am finished my presentation by handover my next fellow teammate.
Hello, myself Tasnim Khan Liha, and today I will present a display circuit design using 555 timers. Here there is a 12 Hz clock with a 60% duty cycle, giving us a high time of 50 milliseconds and a low time of 33 milliseconds. Using the standard timing formulas, we selected component values: a 250 microfarad capacitor and a 220 ohm and a 180 ohm resistor to achieve this exact pulse which will drive our state machine. Into my next slide, there is a FSM design for output A and B. This pulse controls a simple two-state finite state machine. State A activates the output A for 4 clock cycles, then transitions to state B, which activates output B for 4 cycles before returning to state A. Together, these two components, the 555 timer and the FSM, create a reliable alternating control system for our outputs. Thank you, and I will now hand it over to Syed to present the next topic.
Assalamu alaikum. My name is MD Said Al Shaf, and I am going to explain the FSM state diagram of our digital control parking system. So FSM stands for finite state machine, which means the system works by moving through a fixed number of cars of states. Each state represents a specific condition of the parking. So when a car enters uh, or the car present or the car exit. The transition from one state to another state happens for the sensor input. For example, when a sensor detects a vehicle is entering the system, changes its states and increases the count as the system see the car is going out, the increases the decreases the count. The FSM state diagram helps us clearly understand working flow of the system and ensures that parking count remains accurate and controlled. Now let's talk about FSM stable. FSM stable is a simple table representation of the state diagram. It shows the present state of the system, the input condition, the next state, and the output. Using the table, we can easily understand how the system behaves for every possible input. It helps us implementing the logic and in the hardware correctly, avoid confusion during design. The state table also makes debugging easier and ensures the system. Thank you everyone.
Assalamu alaikum everyone. My name is Ashfaq Ahmed Ashfi. Today I told about digital parking control system. My topic is limitation and modifications. Limitations. There's a four limitations for the control. It's sensor reliability, capacitor limitations, 55 of timer accuracy, and standalone operation. Sensor reliability, the system depends on entry and exit sensors which may given correct counts due to minimum noise conditions or environmental. Capacity limitations is a 4-bit of their supports to the 15 counters to the limit the 9 requires, and then 555 from the timer accuracy and the and the component temperature control. Standalone operation is the system backwards remote monitoring and data storage problem and is smartly problem handling. Next is the modifications is the higher capacitor to the size to be increased the 7 bits of up to 100 cards each, which is the improving their still scalability by the scrapping this components to the FPGA allows the timing, the flexibility capacitor controls it, the easy to integration and with the low functions. This changes the elements of the 555 timer capacity, improving accuracy, the system flexibility. Thank you everyone. Assalamu alaikum.